I'll just quickly refresh once again that fire life safety system, we call it FLS system, is a system which is designed to protect the lives in the building. Okay, so and this is designed based on the codes and standards, and NFPA is the most like the favored, like you can say that you most famous codes around the world. Even all the countries have their codes, but most of them are following NFPA. Okay, so the learning we are going to take here is we are going to refer the NFPA and we'll go according to that, because almost all the codes are kind of replica of the same. Okay, so little bit values will be different and rules will be little bit different, but mostly it will match. So we cannot learn all the countries code, but we will learn one code NFPA, and then from there we'll take the references and we'll try to understand this service. Okay, so in that service, the I was explaining the plant room, you know how it works. This plant room which is finished, maybe I'll publish the video of the recorded session. Okay, so you can refer back from there if you have not joined that time. But today I will explain you the whole and soul. So basically I'll just refresh once again and then we'll explain you the all, you know, other part of it. So basically fire and life safety is a system which is designed to protect the life in the case of fire in the building. Okay, simple. There are two kinds of fire and life safety system. One we call it active system and another we call it passive system. So passive system is about the design of the building itself, so that the people can you know get out from the building in the case of fire very quickly. So that part is also there, which is basically for the architects who are designing the building. They have to take care of those things, that they have like minimum width of the staircase is required and the minimum number of staircase is required. Okay, so assembly, the requirement of assembly point, the travel length distance, the building should not be too long that the people cannot run, you know, it takes a lot of time to come out from the building. So these all things are kind of passive systems. Okay, so we need to design the building in such a way that the people can come out from the building very quickly. So that system we'll see later. Those are just like hard rules you need to follow as a architect. But for the other services, like you know, the for the people who are coordinating the services, they are responsible for the active system. So active system is the once fire is there, like you know, is happened, then after that how to suppress the fire and how to fight with the fire. Okay, so this is all about that one. So in that design, first thing you need to know that for which type of building we are designing. Okay, so for which type of building we are designing, and in that sense first thing you need to know that what are the types of building. Okay, based on the height of the building we have a classification. Okay, so that we'll learn first and then we'll go further and we'll see this system. Okay, so you should take a note and write down whatever I'm going to tell you, because you cannot remember it in your mind, you will forget it very quickly. Where is it coming from? Who is that requesting on? Okay, so first is a low rise building. Okay, so we have four kinds of buildings. Okay, four kinds of building based on the height. So first we call it low rise, second we call it mid rise, third we call it high rise, and the last we call it super high rise. Can anyone tell me what are the heights of those buildings? Do you know? Anyone? So there are basically four kinds of building: low rise, mid rise, high rise, and super high rise. Okay, so you can note it down now. So the building up to 15-meter is low rise. Okay, and the measurement of the building will be from the lowest grade till the roof. Okay, and you will exclude the parapet, you will not count the parapet height. Okay, the parapet means the boundary on the last floor, the roof. Okay, so that will be not counted. Other than that, like up to the roof level. Okay, so from the lowest grade means suppose your building has a ground floor, you will not measure it from the ground floor. Okay, so first you need to understand that from where will you measure. Okay, so let's say this is your building, this is your ground floor level. uh, So this is your ground floor level and this is your roof level. So you should not measure it from here to here, because ground floor itself is on some height, right? It's already on the plinth. So for example, maybe there is a plinth like this, or maybe basement is there. So from where you have to measure, maybe the after the ground floor there is a grade level. Grade level means the road levels are there, and then after that road levels. So you are making, let's say, roads and all, like, so roads are obviously not same height of the building, right? So it's like something like this. So your car is running here, maybe basement, you forget about that, basement will not count it. So the distance will be not from the ground floor, sorry, not from the ground floor to roof, but the from the grade level to the roof floor. But this grade level also is not the grade level whatever you can see. Maybe multiple grade levels can have, like, in a building we can have multiple kinds of roads which have the multiple slope. So the lowest point, whichever the grade which is at the lowest point, from there we will count, okay, till the roof level. Okay, so this is how we count the distance of the building. Okay, so this confusion is gone. Now 15 meter, up to 15-meter building, we call it low rise building. Okay. From 15-meter to 23-meter building, we call it mid rise building. Okay. Then 23 to 90-meter height building, we call it high rise building. And 90-meter and above, we call it super high rise building. Okay. Now I'll quickly ask the question, you have to answer. I will just tell the distance and you have to tell that this building is in which category. Okay, so let's say I have a building of 45 meter, in which category it should come? 45 meter, who can tell this?
High rise category.
High rise categories. Okay, let's say I have a building, the from the lowest grade, the height of the building is, the height till the parapet level is 90 meter, in which category that building will come? From lowest
Super high
grade,
rise.
yeah, from lowest grade till the parapet, 90 meter, which category?
Still high rise. High rise building.
Why not super high rise?
Mm.
Because the length of parapet is excluded,
Super
we
high
cannot
rise.
include that one, right? Okay, so we always in the fire way, if you look the distance, the height of the building from the perspective of fire system, then you will always count the landing where you land. You will never walk on the parapet, right? You will always walk on the floor, which is the, so basically from the lowest grade till the um, floor level, right, of the roof. So I'm telling 90 meter till the parapet, so it means obviously it is the roof floor level itself is all, maybe it will always less than the 90, because parapet is always not comes less than 1.2 meters, right? So you can say that this building is, in any case, always it will be less than 90 meter, because the height from the grade level till the parapet is 90 meter. It means the till the roof level, the distance obviously is less than 90 meters. So which comes in high rise building, not in super high rise. Correct? So that's how you count it. Let's say up to the my building height up to the parapet is 15 meter. Then in what category it will come? Tell me quickly. It's not very big deal, right? To tell these all things. I think most of you
Uh,
guys did not write it. That's why you cannot tell it. Yeah, tell me. Someone was telling.
it's a low rise building.
Yes, low rise. So be very clear. Distance will be measured from the lowest grade till the roof floor slab. Okay, and that if it is less than 15 meter, it's low rise. If it is from 15 or above, but not more than 23, in between whatever the height building is coming, that is mid rise. From 23 meter to 90 meter, that is high rise, and from 90 meter to above, super high rise. Got it? Okay. So from there you can classify that which kind of building I'm working in. Okay, so from there, because the fire codes drastically changes the according to the type of building. If it's lower, the rules and regulations changes, according to that, which will cover, we'll see. Okay, it will affect. So but before that, you need to know that which kind of building you're working on: high rise, super high rise, or low rise. So basically, that is it about the building type. Then the type of buildings, you already know that it's a residential case, or it's a, office, or malls or hospitals. Okay, that is a category of the building, that is separate thing. I'm speaking about the height of the building. Now we will come and we will see that in the active system how the fire systems are installed. Okay, so if the system, the active system, there are three system basically, which is the use of water to suppress the system. Okay, so wet system normally we call it. Okay, so in wet system there are three kinds of combination of the system which makes the fire complete system. Okay, so first system is, we call it class 1, second we call it class 2, and third we call it class 3. Okay, so in that first class we call it landing valve system. Okay, I will explain you now. After that, first you understand that, you can write it down also. Then second is hose reel system. Okay, and the third is the combination of landing valve plus hose reel system. Okay, so that is class third. Okay, so there are three classes of firefighting system. Okay, and this is excluding the sprinkler system because that is a completely separate system. I'm just speaking about the standpipe system, which happens like the water is there available in that system, but the fighting has to be done manually. And sprinkler system is automatic system. The sprinkler system is not manual system, like person has not to be there, but to operate the standpipe system, you have to, but the person has to be present there. Okay, so this is for the manual operation. Okay, now, so in this building, this is a pump which is driving the both system. The wet riser system, we call it, the wet riser system is manual operation. Okay, and then the sprinkler system, which is automatic system. Okay, and this is the pumping system which is responsible to pump the water inside it. This all explanation I already finished it, like how these arrangements are there and how you have to do the plant rooms and all. Now from here onwards, you will understand today how the system is in combination works. Okay, so this system is wet riser system. The blue line you can see it here, right? So, and this red line is sprinkler system. Sprinkler is automatic system, and blue line, which is wet riser system, that is a manual system. Means manual system means the water is automatically filled here, but the operation has to be manually. The person has to be there to fight with the fire. Okay, now in that we are now discussing the class 1, first, second and third is only about the wet riser system. Okay, about this blue line system. So in that case, the class 1 will consist of landing valve. Now what is landing valve? Landing valve is a valve where you can connect the pipe, and which is normally situated in the staircases, not staircases but the nearby staircases, because that is the most accessible location in case of fire, to come for the firefighters and to get the water from there to suppress the water. Okay, so that system we call it landing valve system. Okay, so one valve will be there, so that basically comes like, I'll show you in the picture. So landing valve. Okay, so maybe installed, I'll show you, not that one. Okay, can you see this one? This is landing valve. Okay, and this is hose reel. Okay, this is landing valve and this is hose reel, and this is the stand pipe. Okay, and the combination of both, the complete system, we call it wet riser system. Okay, the combination of both. Now one thing you have to care very carefully, that this system alone also can come. Okay, according to the classification of hazard cases, this system alone also can come. Maybe if the building is like G plus 1 or 2, then in that one this kind of standpipe is not required if it is residential. Let's say it's not big hospital or all along, so that criteria is different criteria which designers will take care. You have to understand the system. Okay, so this system alone also can come, and this with combination also can come. Okay, but the building type you are going to work like up to the mid rise, unless otherwise it's a very small, you know, villa and like 1G plus 1 2 building, you will always get this both in combination. Okay, but if this comes alone, it does not mean that design is wrong. Okay, that also can happen. So in that case, don't tell that your building is small, some kind of, you know, a small building, and if only veterizer is coming, then don't think that that design is wrong. Okay, but so that if this alone is coming, that is class second. Okay, and that is called hose reel system. Okay, and in some cases this also will be not there and this alone can come, and that we call it landing valve system. Okay, and if both, and that is class 1. Okay, so if only landing valve comes, it means class 1. If only this hose reel comes, that is class 2nd, and if both with combination will come, that is class 3rd. Okay, so that you know it. Now this is not needed to be you know, you don't need to remember all these classes, which is class 1 2 second 3rd. I'm just explaining you for the reference, but you need to understand what is the difference between the hose reel system, the landing valve system, and the wet riser system. So hose reel system means only hose reel will come. Okay, landing valve system means only landing valve will come, and wet riser system means both will come. Is it simple now? Clear? These three systems are there. Now you need to note some items. Just take your again your notebook and pen. Okay, so this hose reel system connects with a pipe, a hose. The dia of that pipe should be 25 mm, and the length of this hose. Okay, hose reel means what? It is a reel on which hose means pipe, like flexible pipe. Okay, is, you know, wrapped around it, and this is ready with the water. So what happens, so once the water is ready here, and in case of fire, anyone can just open this valve and they can start throwing the water by using this reel, and then this reel can reach up to 30 meter. So note it this down, this you have to reach. So the length of the hose reel is 30 meter, and the size of the hose reel pipe is 25 mm. Okay, clear? And the flow, how much water it will deliver in the operation case, 50 gpm, 50 gallon per minute water it will disperse. Okay, standard, just remember these things. Okay, so the length of this hose system is 30 meter. It means what? It means the any place in the building cannot be, like, you know, wherever, if you are protecting, let's say here you can see that four items are there. Okay, now first of all you tell me what system is this. Is it a hose reel system, landing system, or it's a wet riser system? What system is this?
Weight digest system.
Why?
Because all component has replaced it.
Correct. So here both items are there. Hose reel is also there, and then landing valve is also there. And this complete combination we call it fire hose cabinet. Okay, which is divided into two parts. On the top side there is a hose reel system, and then the below there is this landing valve system. Now the hose reel system is always connected. The hose is already connected. Only thing is you have to push it out and then you have to fight it. The landing valve system, these pipes are wrapped here and it's not connected, it's just kept there. Now why is it? This is meant to be operated by normal people. Okay, not a fighter specialist. This can be operated by a normal people only, anyone who is a healthy person who can operate it. Okay, now this is not meant to be operated by a normal people. If you start, you cannot handle this, you need a special training to handle this. Okay, so that's why there is a two part. Okay, so if a small power, you know, fire is there and someone is available there from the building itself, they can use this and they can suppress the fire. Okay, so basically this will deliver less water, and the water which will come out from here will be 50 gallon per minute. Yes, it means 50 GPM at 4.5 bar. Pressure is also important, so note this down. 20 in hose reel system, 25 dia pipe size, 30-meter long at 4.5 bar pressure. Clear? Now coming to the landing valve. Landing valve is also having the same hose reel system, but the only thing is hose is disconnected. Only at the time of operation they will connect it. They will open this valve. First they will connect, then they will operate the valve, and it will start throwing the water. Okay. So in that case, the connection of this pipe is 65 mm landing valve. This pipe itself is 65 mm, and the pressure of this valve is 6.9 bar. Okay, not less than that, 6.9 bar. Okay, and the length of this hose also is 30 meter. Okay, so it means what, this hose, this cabinet, we cannot keep more than 30 meter anywhere in the building. So for example, now I'll ask the question. Let's say I have a corridor like this. Okay, and another first rule is this landing valve or this hose reel, okay, it cannot be more than 6 meter away from the staircase. Okay, so staircase, and in any high rise building or low rise building, like above than the low rise, excuse me, you always have to have two staircases. Okay, two fire escape routes. So let's say it is like this. Okay, so let's say if what I was telling, first I'll explain, then you will need to answer. Okay, so let's say this is one staircase and this is one staircase. Okay, and the corridor length itself is, let's say this is maybe 45 meter. Okay, 45 meter. So in that case, if I will install a hose reel here, right, let's say it's a 5 meter away, which is acceptable. It should not be more than 6 meter, right? So can it cover till the dead end of what do you call, corridor? Can it?
No. No, sir, because length is too short
This
of hose
length,
reel.
is, the complete corridor is 45 meter, and this is only 5 meter away from the staircase. Okay, and let's say this staircase is covering into 5 meters, so 10 meter maximum, right? So these both are within the 10 meter, right? Let's say I'll just move it here for your understanding purpose, right? And from here your hose has to travel, but the complete length of the corridor itself is 45 meters. So this is already within the, how much, this is within the 40 meter, right? Sorry, 10 meters, including the staircase, the size of the staircase plus. So this measurement you will always take from the door. Okay, so let's say door is here. If the door is this side, then you have to measure it from the door from here. Okay, so let's say the door is at this side, and from here this is within the 6 meter range. Then from here, if you will start running your hose reel, it will maximum reach to 30 meter, which will cover, means the 10 meter this and the 30 meter that, 40 meters. But still I told you the length of the corridor is 45 meter, correct? So is it enough? Is one fire hose cabinet is enough here by
No,
rule?
sir, because length is not covering.
Yes, it's still we are losing how much? 5 meter, right? So it means we have to give two fire hose cabinet in this. So now, how as a coordinator it's useful for you? So suppose you are coordinating a building, technically you are reviewing that building. So first thing you have to see that how long this corridor is and how many fire hose red cabinets are coming. Or maybe your modeler is keeping only one and your corridor is 45 meter, right? This happens on a consultant stage mostly, because in the soft drawing stage or construction stage you already get some IFC drawings, right? So from there you can see and refer, but there are big chances of that there is lot of chances of error in the IFC drawings also. So whatever stage you are doing, if you are doing the IFC drawing, like you are working for consultants to design these things, that time also you need to be very aware of these services, whether my modelers are doing correctly or not. Okay, because engineers are someone who are always busy in their calculations and all and preparing a lot of documents, so they cannot come and monitor you all the time. So these things you need to know, and these things the engineers also depend on you, that okay, you should know these basics, so you should give it, provide it by yourself, and later they will just see and they can review it. Okay, so this is like a basic rule of the some people they call it, this is design, this is not my job. This is not design, this is something basics which you should know. Okay, if you know only the modeling in the Revit, then there is nothing which will stop to get it done by a high school guy, right? No need of completing a complete engineering to do the Revit modeling, right? If I'll train a Revit software for a month to any good IQ guy of 10th standard, they can start doing the same work what you are doing, right? They can do it, and believe me, within 6 months they will become faster than you maybe. But why the engineers are expected to do these works? Because of these things, because this is a deep engineering which you need to know, and most of the people they don't know, right? I don't know why. But basically this is meant to be known, right? And it's not rocket science. Very quickly, very easily you can understand it. Okay, so now what we were learning is this length. So this is how you can decide that my hose reel cabinets, if I'm placing, my modelers are placing, is it correct? Or suppose to cover this board 30 meter, he is placing here, is it correct? In the mid of this corridor he is placing, is it correct?
No, sir, it's wrong because our firefighting system away from staircase.
Correct. So it must be within the 6 meter range from the staircase, right? Now, if you are architect and you are designing this staircase, like let's say this staircase is here and there is no staircase here, because of your smartness, you kept it in the mid, so you can cover this all. Is this correct? Is this correct? Now you can cover
No, sir,
15 meter, 15
because
meter. Hmm. Why?
no, sir, firefighting system away from 5 meter from staircase.
Hmm.
In this case, we we get left or right because area is
No, no.
more than.
This is already 5 meter, within the 5 meter. This is staircase. The rule is this hose reel cabinet cannot be more than 5 meter away from the staircase. Now here is the staircase. 1 minute. Here is the staircase. I'm just with the staircase. I'm keeping my hose reel, so it's not more than 6 meter, right? Let's say it's together, and our complete corridor is 45 meter. So now from here anywhere he'll go, he can reach, right? This is not, if the total is 45 meter, the half of that one is how much? 22.5, right? So it is within 30 meter range, so it means it can cover from here, it can cover this also, and it can cover this also. Let's say this is in the mid. Okay, so how is it wrong? Logically tell
No,
me.
sir.
Hmm.
That's because our firefighting system covering uh, the whole floor that need.
Who is telling this? 1 minute, can you tell me? Sonu, okay, tell me. How is it
Sir,
wrong?
no, sir, that's not wrong. Because
So it can be
our
installed.
house will are.
So this installation is correct, you say?
Yes, sir. I think
No,
so.
this is also
No,
wrong.
no,
Can someone tell
no
me why
wrong
it's
there.
wrong? Why it's wrong?
Because in a building we need two fire exit stairs,
Correct.
and there is
So
only one.
so the that is a part of passive system. I told you, no, you remember I told you the passive system and active system. So that rule belongs to the passive system of the building design. So you must have two staircase, two fire escape routes, okay, in the building. So for that purpose, obviously they will keep into the like this, right? And in that case you cannot have the two. So basically you have to arrange two landing walls, sorry, the fire hose cabinet in this building. So is it too difficult to check this? It's so easy and logical, right? The only thing you were not aware to check this before, because you was not aware of these rules at all. And these rules are not so a big complicated rule that you need the Einstein kind of brain to understand it, right? That's only one time you will, someone will explain and you will always remember. So this is so simple to learn. Okay, so now you understand the placement of the hose reel system, sorry, the fire hose cabinets. Okay, fire hose cabinets in the any building which you are doing, which is not very small, like villa and small buildings, you will always get in combination. Okay, and the rules are very simple. The connection of the hose reel system will be 25. The length of that reel will be 30 meter, and the pressure in that pipe of water will be at 4.5 bar, and the delivery of the water per minute will be 50 gallons. Okay, you note it down, you remember it, it doesn't change. This is the code, this is the rule, that's all. Finish. End of the story. Okay. Now, if you'll know this way, the buildings, if you'll read this way, the building drawings, and if you'll explain this in a meeting or if someone is explaining, that's when you sound like engineer. If someone is asking that is it wrong or wrong, you say this is designer's work. This, I'm a modeler, I'm a coordinator, I don't know, this is not my part. Okay, then you look irresponsible. But if you know this, then you sound very mature and you look professional. And the funny part is it's not too complicated to learn. It's not very difficult task to learn. Okay, so now we learned this system. So why we came here? To understand this system. Okay, lining valve system. So 1 minute, I'll delete this one. Okay, so this system is wet riser system, right? So, and this is combination of that. Okay, you see here. Now the piping of, okay, this happens based on the hydraulic calculation, but still I'll tell you that in any wet riser system you cannot have the pipe less than 4 inches, which is 100 dia, 100 dia. Okay, so if someone is providing 75 dia for the connection of hose reel system, is it correct? The riser pipe means from where the distribution is happening, it means you can say the main pipe. Is it correct? 75 dia riser
No,
is given in fire hose
no,
cabinet.
sir.
Not allowed, right? The rule
Not
is
allowed.
it cannot be less than 100 dia. Okay, so that
Yes.
point is also there, we need to check. So suppose your modeler is made, let's say he understood that, okay, that this is 65 dia, this is also 65 dia, and this is 25, so maximum pipe size here it's going is 65, so I will arrange the 100 dia, right? But yes, in one case you can do it. In which case, if only one landing valve is there, like only one fire hose is there, in that case you can give it. But we are speaking about the multi-story building here, so of course 2 floors will be there. So always two, cabinets will come. So in that case, your riser must be 100 dia. Okay. And if someone is giving 50 dia itself to connect this hose cabinet, like FSC, is it correct? That also is not correct. Why? You need the minimum 65 dia. Now, one question you should ask technically, which one none of you asked me, that here you see this requires 6.9 bar pressure, which is higher pressure, and this requires 4.5 bar, which is lower pressure. Why 4.5? So that a normal person can handle. Why this is 6.9? So that it can reach to the longer space and it can suppress the water more quickly. And this is to be operated by firemen, so they can handle it easily. Okay, not easily, but they can handle it at least. So how do you put it? Like the same pipe is connected here, and this system is connected, require minimum 6.9 bar, and from the same pipe if they are giving the connections to this system which require not more than 4.5 bar, so how they will do this connection? It means this will also deliver the same kind of pressure, right? If here it's coming 6.9 bar, of course here also you will get 6.9 bar, but the rule is you cannot have this more than 4.5 bar, because a normal person cannot handle the pressure of 6.9 bar. That's why this is combination of PRV. Here there is a one PRV system, okay, pressure reducing valve. So this connection will always happen after the PRV. So it up to here it will come 6.9 bar, but it will reduce and it will make it 4.5 bar. Then only it will connect to the hose reel. Correct?
Okay.
Okay. Hmm.
No. Yes.
Yeah. Okay. Now this the center of this pipe, the landing valve from the FFL should not be more than 900 mm when you are going to install. Okay, this complete length can be more than 900 mm, but the center of this landing valve from the FFL means finished floor level of your that particular corridor wherever you are installing it, it should not be more than 900 mm from the FFL to the center of this one. Okay, so suppose you got this submittal of this one or family of this one, and your modeler placed it this one point, like he arranged it in such a way that this is coming on 1.5 mm. So is it correct? Is it correct? Why you guys are not speaking? Is it too difficult to understand or what? Hello? Wait, I'll put it from the person's name. Okay. Anish, you tell me. Anish is on hold. Who else is there? Nagesh, tell me. Nagesh, if my modeler is placing this fire hose cabinet in such a way that the center of this hose cabinet, like this fire hose, what do you call, landing valve, is 1.5 meter from the FFL. Is it correct?
No,
No,
sir,
sir,
it will
not.
be depend on.
It will depend on what?
Hello.
It will depend on what? It will depend on nothing. The rule is it cannot be more than 900 mm. Okay. So it has to be either 900 mm or less than that. So if he is installing at 700 mm, that's fine. Okay, but if he is installing at 1.5 mm, it's not fine. Why? Because the rule says it. The NFPA guide says that if it will be too high, then it will be difficult for firemen to connect it, the pipes. Okay, so the 900 mm is the ideal height where they can push it. Okay, or lower than that. So now see how many points you can see and check if your modelers are working correctly or not. So suppose he is placing a fire hose cabinet, and let's say this according to the length of this one, the length from the bottom till this fire hose, this cabinet is, let's say, 400 mm. If you are keeping 400 mm away, in that case the center of this landing valve is coming 1.2 mm, like 1.2 meter, which is 1200 mm, right? So by selecting this, you can understand that even in the Navisworks you can measure it, that this distance. So but from there you can decide it. If this will be 200 lower, it means if the bottom of this cabinet is 200 mm away from the FFL, in that case this will fall on within the 1000 mm. Okay, but we need 900 mm. It means we have to reduce another 100 mm. So to achieve this within 900 mm, the bottom of the your fire hose cabinet should be 100 mm away from this FFL. Let's say that is not the actual case, I'm just giving the example. Okay, so now you know that you checked one place, that fire hose cabinet must be within 100 mm away from the floor. So somewhere you find that your modeler has placed this 500 mm away from the FFL, then automatically you need to know that the placement is wrong. Okay, you got me?
Yes, sir.
That's how you technically check the model. Okay, so this is something rule this is what I call it visual checks of the model. Okay, visual checks of the model. So then this system, what I was telling, okay, so this system is clear, like fire hose cabinet system, is it clear?
Yes, sir.
Okay, now one thing I left here, what is the flow rate of landing valve? That is 250 GPM. Okay, so the flow rate of the water, how much it will deliver? 250 GPM. So these all things also you can note it down. Okay, so I will just refresh once again. The fire hose cabinet consists of two items, not two items, two more than two items. These items are also there. Fire extinguisher, which you will see separately. We are just looking into the wet service. These fire extinguishers are there, but those are the gas bottles, like the extinguishers, basically cylinders with the filled with the carbon dioxide and all. So that is also kept in here, but basically weight system is connected with two items. One is with the landing valve, another is with the fire hose reel. The fire hose reel is meant to be operated by the people, the normal people. The landing valve is meant to be operated by the fireman or the expert people who comes from the municipality in case of fire. This has to be on the 6.9 bar pressure minimum, and it should deliver 250 gallon per minute of water. Okay, this will deliver only 50 gallon of water per minute. The pressure will be 4.5 4.5 bar, and the length of the hose is should be 30 meter, and this also the length of the hose should be 30 meter. Okay, so only by knowing this much small information, see how many things you can check in the building, that whether the placement of these things are correct or not. Or even if the placement you and now you see how it can benefit with your coordination. So if suppose you are placing somewhere where the electrical db is coming and you need to move this, right, because that is the best location for your electrical db. So now when you are moving this, if you know these rules, very easily you can, okay, within that range I can move it, you know, up to where you can move it. But if you are completely blank about the system, the criteria, then you cannot move it. You don't know I should go left or right, or even if you are moving it, you don't know you are doing it right or wrong. Okay, so that's why it is important to know these things, like basic rules. Okay, this is the basic, I call it golden rules of the coordination. Okay, so basic golden rules you need to know for the all services. And some people they told that argument that I am electrical, so I should not know the fire, or I am fire, so I should not know the electricals. I'm not telling you to go deep and study this complete design system of this. I'm just asking the basic rules, if you know, because you as a coordinator you have to coordinate with all services. That's how this role is. Okay, and you cannot compare with the traditional method where all the persons were doing all the services separately. That's why the lot of chaos was also there that time. So BIM, it is giving advantage to combine all the services at the same place and do the constructions, the drawings quickly with correct like certainty, where you can construct it as it is, like whatever you designed. The previously when the CAD file was done and all people were doing their all services, maybe they are correct in their particular service, but when you overlap all these services, it's clashing to each other. Okay, not in the proximity. So because of that, the site guys were facing a lot of problems. Now those problems we are fixing in BIM in the software itself, but that's where the responsibility comes more. There should be one person who should know all these things, who can quickly ask the other guys to move within the limit, so that they can quickly work around it. So suppose the fire person, you are keeping on fire modeler who is doing the firefighting modeler, another is electrical modeler, but they both are working under you as a coordinator. So if both the items are clashing with each other, then you are the one who should tell them that which should be moved and how far it should be. Okay, so that is the rule of this firehose cabinet. Now and this system I explained already. I will maybe publish the video, that time you can see it. Most of you guys were not there. So basically I will just cover it from here. So first of all, this system, pumping system, is the same. From there it's coming, and this has the PRV system, because maybe to deliver the sprinkler at the end, or to deliver this pipe at the end, like pressure at the remotest place always we consider. Okay, and the pump sizing is a design part. Still I will tell you that when that fire person, the fire designers, when they design this piping system, they consider one fire at one case. So they will think that the design criteria is one fire will happen at one floor. So okay, so they will consider that way, and that way they will design it. So the system is not meant to operate all the fire hose cabinet of the building at the same time. Okay, so the pump, suppose he is selecting the pump. Okay, so he has to consider one floor at, one fire at one floor. Now the consideration while designing this, I'm going to design, you don't have to remember it, but just I'm giving you for reference. Okay, so when you're designing this fire system, so you need to consider, suppose if you are designing it for the remotest location, so remotest location is of course on the roof. And then one more you have to consider as extra for the safety of factor, that the roof, the floor below the last floor should also operate, like you have to count it. So when these both fire hose cabinets are working, at that time what are the maximum demand will come? 250 GPM this landing valve and 250 GPM this landing valve. It means to overall the flow rate of the pipe should be 500 GPM. So in that way you cannot have the pumping system less than 500 GPM in any case. Okay. Now you will get the 500 GPM catalog from the supplier, and then you can see that your motor is fitting here or not, like the complete pumping system is enough or not. So and here also arrangements, I told you that this header should be not less than 1.2 meter from the pump. Okay, the suction header, this header to the pump. So these all things if you know, then you know that my plant room is enough or not, like space wise, is it too compact, or can I arrange my all services or not, that way. Okay, so anyway, that is covered now. So from here we are covering, so this system is uh, connected like this. Now we understood the installation here. The pipe size being understood, not less than 100 mm, and the pressure of the remotest location should not be less than 6.9 bar. Okay, and then top of the each riser you have to keep the AV, air automatic air vent, which will act like air vent. Okay, air vent, why? Suppose anytime when you will clean this pipe, like the maintenance time, if you need to remove the water from there, then it will not go back, because if it's everything is filled already and you are not giving air to come back to fill the space, it will create a vacuum, negative pressure, so it will not allow you. So you need the AAV. So AAV, how it works, when the water is going from this side it will stop, and when the water is coming from that side to back side, then it will open and it will allow water to go, sorry, air to go to fill the space where from the water is going back. Okay, now again, and this FSC should have a drain point. It should be connected with the drain for testing purpose. Suppose in the testing mode, if they are testing this or this, that time the water has to go. So from here normally that comes in drainage, they are not showing here, that's why. So that or what they keep it is, they keep on another pipe here, drain pipe, they call it drain pipe, which should not be less than 75 mm. Okay, and that they connect the, there is a pipe here, from here they can connect to the stand pipe, like the drain pipe. Okay, but here they have not shown that, you can show in drainage also. Some people, that if you have the what do you call, flow drain, which is connected, which is meant to for the drainage system, in that also you can drain this water. It's not compulsory that you need to have that separate system for that. You have to have a facility where you can drain the water. Okay, so this is that system. AV you understood, all the items which is coming in between you understood, this firehouse cabinet you understood, placement of this item also you understood. Now another system is there, this is combined with another system called breaching inlet. Okay, breaching inlet. So this system is meant to be operated in two conditions. First condition, if the pumping system is working, then it should give the water to the system. Okay, so pumping system is already giving the water to this system. Okay, the another system is the breaching inlet system. Suppose this water is finished or the motor is not working, this pumping system is not working, in that case your, you can close this VFB, or even the NRV is also there. So in that case this pipe is connected with the breaching inlet. Breaching inlet something from where your fire truck, the person who, the fire persons, they comes from the municipality, they can connect their truck and then they can fill the water here, and their pumping system is also there. They have the ready-made system, everything loaded with the water and everything. So they will just connect this pipe, and from here the pipe water can come and it can go in this system, and from there then the another fireman who is operating the truck, they will connect their hose to this fire breaching inlet, and then breaching inlet, from here the water is going and it's going to the floor, and the another fireman will go to that particular floor, and then they can operate this hose reel system. Okay, so what's happening, we have the backup system. Either they can directly operate it from the fire truck, or they can operate it from the pumping station, whatever working. Okay, so just like a backup system. Okay, so that's why, so one breaching inlet also should be connected with this pipe. Okay, after the pumping system. So that is it, this one. Okay, now this breaching inlet should not be more than 18 meter away from the building. Okay, and it should be always on the accessible position where the truck can go and it can turn. Okay, so again your person is putting this suppose your building is here. Okay, and your road is this side, and this guy is, and here there is no road. Okay, and here he is placing the breaching inlet. Is it correct?
No, sir.
Why?
Because this is not accessible easily.
Correct. It has to be accessible from the
Hmm.
road. Okay.
Directly, yes. Yes.
And this road and this itself, if you are keeping it away, it should not be more than 18-meter away, and it should be at the accessible location, like nearby the road. Okay. And from where the truck can come and they can stand and they can connect that breaching inlet. Okay. Breaching inlet looks like this. I will show you. So something similar like this. Breaching inlet. So this is the breaching inlet. Okay. The four-way, two-way system, that is separate thing. You just understand that this is the arrangement where these firemen can come and they can plug their pipe in this one, and from there the water will start flowing and it will flow in the system, and from there they can go and they can suppress the fire. Okay. So today we learned the NFPA 14, okay, which is about the standpipe. So is it clear enough? This is what you will get in almost all the projects. Whatever kind of projects you will get, there is no separate system. There, the code itself is a very long for the installation guide, this, that, but there is the designers and installers part. But you as the BIM coordinator, you need to know this much. That's all. Okay, about the not fire system. This is not the complete fire system actually, but the wet riser system. Okay, so this is wet riser system, and this is the rule of the wet riser system. Okay, is it clear? Same way we will learn the sprinkler system. Okay, and we already finished the pumping system. Then your fire wet system will complete. Okay, then other specialist service will come, like the deluge system and the FM200 system. Those are the gas and the more water spray system. That is a separate case which is smaller than one, like which is not used in the all places of the building, but very critical areas they are using it. But 90-80% of volume of your work in modeling and coordination, you will get only these two items: wet risers items and the sprinkler items. Wet riser, now we finished it. Tomorrow we will learn the sprinkler system. Fair enough? Was it easy to understand, guys?
Yes. Yes, sir.
So did you learn, what did you learn today new? You have noted down or you are just remember in the mind? Because I'm not going to provide you notes, because I want you to not be dependent on the notes, because you can find it from anywhere internet, and but you'll never use it. But if you practice it, it will come to your work. So that's why I was telling that what always when you come for the session, you need to have the notebook and pen, note it down. I will always explain only the items which is really required. If you go and try to study that code, it will be like 200 pages, and you'll be like completely submerged in that one, and once you'll come out from there, you don't know how to process those informations, where will you use the project. You take the code, you take only the part what you require to complete your job, and that's enough. Don't go in deep into that subject again. So only things as a beam coordinator you require in the wet riser system is this much, the what I explained you. Okay, and same way we need to understand all the surfaces of the building. So in the fire system we are looking into the wet riser system, then we look into the sprinkler system, then we will look into the what I call this gas suppression systems, whatever is there, the pre-action or deluge valves. Okay, so these all systems will cover, and then we'll close this. Then we'll go for the HVAC system. Similar way we'll learn what is the rules and basic criteria of HVAC. Same like that, power, lighting, okay, fire alarm, smoke management, like this. All the subjects once you will cover, you will have a plenty of knowledge to complete even super high rise building. Okay,